Hello, everybody. In this video, we are going to learn how to write the domain and range of functions using inequalities. Now, for this standard, we're actually going to be mastering three standards at once: A2A, A6A, and A9A. So I've combined them all into one standard called A269A. So we're going to be writing domain and range for all of these functions. Before you start your work, make sure your name is on the title of the slides. Don't delete the full name, just add your name in the front over here. Make sure you share it with me as an editor. When you finish your work, please submit your website link into Canvas. And as always, on this video, there are sharing and naming instructions. If you're using a Chromebook and you want to split screen, here are the shortcuts to split screen so you can watch the video and work on your slides at the same time. Now let's talk about some important definitions. So what is domain and range? Well, domain and range are just sets of numbers, and they are sets of numbers that correspond to a function. So any function has its own domain and range. So what is domain? Well, the domain is the set of inputs, or we could say it's the set of x values, or we could say it's the set of independent variables. This is basically anything that we can put into the function that comes from our domain. And so our range is the opposite. It's the set of outputs, or it's the set of y values, or dependent variables. So anything that we get as a result of a function is in our range. Now, when we are describing these sets, again, domain and range are both sets of numbers, we're going to use what is called inequality notation. So inequality symbols that we have are greater than, less than, greater than or equal to, or less than or equal to. And throughout this slide deck, you're going to see these symbols to copy and paste. You can also insert them as special characters, but for now we can just copy and paste them. If you need to learn more about inequality notation, please complete the activity called Write with Inequality Notation that is on our playlist. I'm not going to cover that in this video. The other thing we need to know before we get into this is that on our graphs, we're going to see open circles and closed circles, and you need to understand what that means. An open circle on a number tells us that that number is not included in our set. So if you see an open circle, you're only going to ever use greater than or less than because it's not equal to it. And if it's not equal to it, then it cannot be in our set of numbers. If you see a closed circle on a number, then that tells us that that number is in our set. So that number could be equal. So we could have it greater than or equal to, or we would use less than or equal to. And we're going to see examples of that right now. So let's jump right in to finding the domain. So we are finding the domain, and our steps are right here, and we have our symbols to copy and paste. The first thing to do when you're looking for the domain of a function is to look to the left side of the x-axis to find the smallest x value that appears on our graph. So I'm going to take this red line, I'm going to move it to the smallest x value that appears on the left side of our graph. And so right there, it is -11. The next thing we're going to do, step 2, is to look on the right side of our graph to find the largest x value that appears on our graph. So I'm going to take my red line, move it all the way over here, and it looks like it lands on 11. Now again, I want to make a point of saying that on the left side, we see a closed circle on -11, whereas on the right side, we see an open circle on +11. And so step 3 is to write an inequality with x as our variable. So x could be any number in between -11 all the way up to, but not including, +11. So the way I would write that inequality is -11 is less than or equal to, copying and pasting that, x, which is our variable for the domain, but x has to be less than positive 11, strictly less than positive 11 because positive 11 has an open circle on it. In our second example, we're going to do the same thing again. So first I'm going to look to the left side of my x-axis and find the smallest number that appears on the graph, and it's there at negative 11 again. This time it's got a closed circle. In step 2, I'm going to bring this red line to the right side to see the largest x value, the largest value that my graph has on the x-axis. Again, I'm looking at the x-axis, and there it is, positive 9. So here we can say that our domain is going to start at negative 11, and since negative 11 has a closed circle on it, we know that it could be equal to negative 11. So we're saying that negative 11 is less than or equal to x, which is less than or equal to 9. So our variable x can be any value in between negative 11 and 9. And it could be equal to negative 11. It could also be equal to 9 because we have closed circles on those values. Our third and final example of finding the domain. Again, step 1 is to take a red line and look to the left side of the x-axis and find the smallest x value that appears on the graph, and it looks like it is at negative 7. I'm going to take my other red line and move it to the right side of the graph, find the largest x value that appears on the graph, and it looks like it is at positive 6, but this time we have an open circle on positive 6, so I know that positive 6 is not going to be equal to our domain. So we can say that this domain is negative 7 is less than or equal to x, which is our variable for the domain, and x is strictly less than 6. And again, I'm using less than 6 because there's an open circle at 6. So x can be any number between negative 7 up to 6, but not including 6. Now, when we are finding the range, we're going to basically do the opposite. Last time we were looking at the x-axis, this time we are looking at the y-axis. So the first thing to do is look at the bottom of the y-axis. Find the smallest value our graph has on the y-axis, and here it is at negative 2. And remember, there's an open circle there, so negative 2 is not included in our range. Second step is to take our other red line and look to the top of the y-axis and find the largest y value that appears on our graph, and it looks like it is at positive 10. And so for our range, I can say that the range is negative 11 less than or equal to y, because y is our variable for the range, and y is going to be less than or equal to 10 because remember 10 has a closed circle on it, so y could be equal to 10. I'm going to copy and paste that there. Now we have our range. Our range, which is our y variable, can be anything from, oh boy, I've made a mistake. Look at that, a live mistake. So what I did wrong was I was looking at my x-axis. I should have been looking at my y-axis. So our range is actually going from negative 2. So remember, in range, we are looking at the y-axis. So y can be anything from negative 2 to positive 10, not including negative 2 because there is an open circle there. And there is proof that even I make mistakes in mathematics, and I just learned from that. All right, example number 2. Again, to find the range, we start by looking at the bottom of the y-axis and finding the smallest number that our graph has on the y-axis. Now, this part is important because it's a little different than the other examples. When I'm looking at the top to find the largest y value, I'm not going to stop here because that's where my point is. I'm actually going to go all the way up here because I see the graph has values up here as well. So it looks like our range this time, the smallest value in our range is +1 because that is where the graph lines up with at the bottom. So +1 is going to be less than y. And again, I'm using less than because +1 has an open circle at it. And the largest value we could have is 8. Up here, we see the y value of these points is 8. And because there is no open circle there, I can assume that is a closed circle. So I can say that y can be less than or equal to +8. This tells me that my range is anything between +1, but not including 1, all the way up to +8. So that is the range of my y values. And example number 3. Again, we start by looking at the bottom of our graph. Looks like this line is already there, and it is at -11. So our range begins at -11. -11 has a closed circle on it, so I know that y could be equal to -11. Now I'm taking another line looking to the top function. It looks like +11 is the largest, but I see a open circle at +11. And so I know that y cannot equal +11, so I'm going to use the less than symbol. So here our range is from -11 all the way up to +11, but not including +11. Now, what if we have a function that has arrows on it? Well, if our function has arrows on it, that means it's going on forever and ever and ever. So we use the infinity symbol to say that a function is going on forever in the positive direction. And we use the negative infinity symbol to say that a function is going on forever in the negative direction. And now that we have the proper symbols here, I can find the domain and range of this function. So the first thing I'm going to do to find the range is look to the left of my x-axis, see that the smallest x value that we have is at 0. So I know that my domain starts at 0. And because it is a closed circle for 0, I know that our x value could be 0. So I'm going to use less than or equal to x, which is our domain variable. Now, when I look to the right of this function, I see an arrow. So that tells me that that function is going to keep on going forever and ever. And so my domain doesn't stop here. My domain actually extends forever and ever. So I know that x is going to go on to infinity. So I can say that x is going to be less than infinity. And since a variable cannot be equal to infinity or negative infinity, we will only use greater than or less than when we have infinity in our domain or range. So this domain tells me that x can be any number equal to 0 or greater than 0 forever and ever in the positive infinity direction. Now let's try the range. Well, if I look at the bottom of the y-axis, the smallest value that we have along the y-axis that our graph has is also 0. So I know that our range starts at 0, and since there is a closed circle here, I know that it could be equal to 0, so I'm going to use less than or equal to y, which is our variable for range. And it's important to know that this line is extending both directions forever and ever. So this line is going to keep going up and up and up as it extends out to the right. And so my range does not stop here. Range does not stop here. The range keeps on going as this line goes on forever and ever. The range will continue to get bigger and bigger. So I actually know that my range for this function is going to go on to positive infinity, or yeah, positive infinity as well. So this range tells me that my y value could be anything from 0 to positive infinity. All right, let's try two more examples here with infinity. In this example, to find my range, I would look to the left of axis, but I see these arrows. So these arrows tell me that this function is actually going to keep going ever and ever in both directions, right and left. So my domain does not start here. It's going to actually just be going on forever in the negative infinity direction. So my domain starts with negative infinity. I would say negative infinity is less than or equal to x. Likewise, I know that my domain does not stop here because this arrow tells me it's going to keep on increasing to the right as the graph moves up. That tells me that the largest x could be is actually infinity. It's going to go on forever and ever. So our domain of this function is negative infinity is less than x, which is less than positive infinity. So really this domain is any of the numbers on the x-axis. Now the range is different because if I look at my range, I can see the smallest y value is here at -1. There is no open circle there, so I can assume that it is a closed circle. So my range begins at -1. And since it could be equal to -1, I'm going to use the less than or equal to number symbol. -1 is less than or equal to y, which is my variable for range. Then again, I have these arrows. So when I look to find the maximum value of my range, it does not stop here. It actually extends forever and ever. So I know that y is going to be going on until positive infinity. So we can just say that y is less than or equal to positive infinity. This range tells me that y can be any number between -1 and positive infinity. All right, here is our last example of using domain and range with positive and negative infinity. Now this is a special situation. So when I look for my domain here, I'm going to look to the left of my x-axis, but I know this arrow is going on forever and ever. So my domain is actually starting forever and ever in the negative direction, which means we are at negative infinity. And I know that x cannot ever be equal to infinity, so I always use less than. And the same thing goes when I look to the right of this graph. This arrow tells me that the domain doesn't stop here. It goes on forever to the right. So I know that x can be less than positive. If x is any number, x can be any number on the x-axis. My domain can be any number on the x-axis. And this is actually going to be the case with our range as well, because if we look bottom of the y-axis, we still have that arrow. So we know that this function does not end here. It actually is going to keep on going ever and ever. So I know my range begins at negative infinity, which is less than or equal to our variable y. I look to the top of this graph. My range does not end here. It keeps on going upwards, upwards, upwards forever and ever because of that arrow. So I know that the maximum our y could be is actually positive infinity. So in this situation, the domain is every single number on the x-axis, and the range is every single number on the y-axis.